I'm going to talk tonight about, I changed my title a little bit because that was done kind of on the fly when Martin asked me if I could give a talk tonight. So it's really, I'm going to focus on really what my real passion is. He mentioned adolescent obesity, but really most of my career has been around looking at trace minerals in infants and toddlers. And so I'm going to focus on complementary feeding and how choices of matter for the nutrition and microbiome and growth, and with just a little bit on each one of those aspects. So I'd like to start, first of all, with just where are we now? And also because this was relatively last minute, I did not do anything to really personalize this to New Zealand, so I apologize for that, and it's very US-centric, but hopefully some of the principles will apply broadly. So I'll start with a little bit on US intakes of nutrients and foods, and really to note that, most people think in the US that there's just no micronutrient problems, and I'm going to argue that there actually are some micronutrient problems. And so I'll bring in complementary feeding studies that we have done, especially in breastfed infants, and then some more recently in formula-fed infants, and to talk about the effects on nutritional status and microbiome and growth. And then to give a little bit of thought to the future of complementary feeding and feeding practices, and where we need to put our emphasis, and to say, I think it's beyond just nutrient intakes, even though that's where my career has really focused, but to really talk about foods and eating habits and so on, and to talk about the role of, the opportunity for industry to actually have some influence there. Clearly they have influence already, and how we might shift that to be more beneficial. So with no further ado, so key considerations for complementary feeding. So this really represents the transition from a single food, whether it's breast milk or formula, to a diet that becomes progressively more and more diverse. And so when you think about what that exposure is to the infant, it's huge. So multiple foods in new and complex and diverse matrices. And probably all of you have heard of the 1,000 days concept, so from gestation through conception through the first 2 years of life. Turns out that if you think of 6 months to 24 months, that's the majority, that's the largest part of the 1,000 days. So this is a very dynamic time when there's a lot going on for the infant, as well as the dietary progression. So it is a time that there's relatively high micronutrient needs because of high growth rates and brain development and so on. And so that means also there's a risk of deficiencies. And globally, there's been many products and strategies to fortify foods as a way to reduce hidden hunger and to reduce deficiencies. Particularly the focus has been on iron and zinc and vitamin A, but others as well, where diets are selectively or more predominantly risk of deficiency. So these new dietary substrates, they influence the growth of new bacterial strains that were not supported by the liquid diet, whichever it was, whether breastfeeding or formula or alternative foods. So clearly there's going to be a huge change depending on what that diet looks like. But when we look at the microbiome literature, it's acknowledged that nutrition and diet is important, but it's kind of like breastfeeding or formula, then a miracle occurs and somehow at 24 to 36 months your microbiome is complete or is mature, and nobody really looks at much detail in between. So rarely are complementary foods actually controlled for in studies of the infant microbiome, and so we've been incorporating this into more of our studies in Denver. So first of all, this is just a nod to macronutrients, but really I'm a micronutrient person. And so this is usual intakes of US infants and toddlers. And so the two bars are infants, the blue are infants 6 to 11 months, and then toddlers 12 to 23 months. And this is from national survey data, and the most recent that we have. So protein, you can see, not surprisingly, goes up and looks perhaps pretty high. When we look at, and what I also have indicated here is the estimated average requirement. So for populations, that's what the figure you should be looking at, not so much RDA. And so you can see for the protein, we're clearly well above that. So grams per kilo looks very generous. And as a percent of energy, some have recommended a max of 15%, and really it looks like on average that's about what US infants are taking. Fat, here we go to AMDR, the acceptable macronutrient distribution range, and here we're up at around 30% for infants, and higher as they go into the second year of life. And then fat as a percent of energy, again, higher in young infants. Just to remind you, human milk is at least 50% of the calories are from fat. So protein, we're at 50 to, the AMDR is 55 to 20%, and so we are really in that ballpark pretty nicely. For fat, 30 to 40% of energy should come from fat. And in fact, somewhat surprisingly, 28%, almost 30% of toddlers have fat intakes less than this AMDR, so less than 30%. So one of the things we see is that the recommendations for adults to eat more fruits and vegetables, low-fat diet, and so on, gets translated down to infants as though infants are young, little adults, and that's, of course, not a appropriate concept. So we really have to, I think, bear that in mind, that the dietary messages we need tailored better to infants and toddlers. We talk about micronutrients, and there are 21 of them that the National Survey tracks. For infants, the estimated average requirement, or the EAR, only for iron and zinc. And the others really, because the data are not as strong, have only a recommended adequate intake. So that's a less precise measure. But the mean intakes are greater, much greater than the AI for most nutrients. Vitamin D and choline are less on average, and they're they are only at 21 and 28% with intakes of of greater than the AI. So maybe those two are nutrients of risk. For iron and zinc, I've got a bar graph here, and so here's the EAR for iron. You see for infants, this is well over the EAR. And then the percent less than the EAR is about 10%, so much lower. This really reflects formula feeding. We predominantly feed iron-fortified formula, and that's why the intake is so high, because it is very highly fortified. For zinc, the story is a little different. The EAR is lower. The intake here, the mean, is well above that, however, and those less than on the EAR is actually, again, quite low. 61% of infants actually have a zinc intake that's above the upper limit. And again, that is probably a reflection of the fortification in our food supply, and also that the upper limit is set a little bit low for zinc. So you can see how these things can kind of shift the message being given. So then when we look at toddlers, all the EARs except for vitamin K, choline, potassium, and sodium are met. And for choline, the mean intake is at 203, and the AI is 200, so pretty close. But 49% have more than the AI intake. And so intakes less than the EAR, vitamin D, 74%, and vitamin E, 82%. But do we really see problems with these? Not so much. So only 10% have vitamin D levels that are less than sufficient. So I think vitamin D is complicated because, of course, we get vitamin D from sunlight, and so diet is not the only source for that. So, but then again, intakes above the upper limit, vitamin A and sodium and zinc all have tendencies to have higher intakes than the upper limits suggested. So, and as I said, for both vitamin A and zinc, the upper limit is set relatively close to the EAR, so it doesn't take much fortification to push you over on that. So, so looks like we're all in pretty good shape, right? So is there any evidence of a problem? And this is where, again, a lot of our work has been done. And so this brings us to the breastfed infant and as our kind of gold standard, and really what does a healthy infant look like? So this slide is showing the dynamic iron status from 0 to 24 months versus infant iron exposure. So what's plotted here are serum ferritin levels on the y-axis, and then on the x-axis is birth out to 24 months. And we don't really need to pay too much attention to the three groups here. This was done at the University of Iowa with Eckhard Ziegler. And what I want you to notice is that early on, ferritin levels are very high. And now as we do delayed cord clamping, they're probably even higher because this has become more common since these data were generated. But you notice that then as the red cells break down, then the ferritin, the iron is reused and the ferritin stores start to become depleted. But lo and behold, by about 4 to 6 months out here is where you start to run out of those iron stores and you need to get it from somewhere else. But really through 4 months, the ferritin levels are still in a very healthy range for a healthy term infant. The trick is to know, are you a healthy term infant or not? So versus, so here's what infants are exposed to. So for a breastfed infant, the iron concentration in breast milk is uniformly low, low, low. So how many of you have learned that yes, but the absorption is high? It doesn't matter when if this was 110% absorption, it's very, very low. Probably for a reason. A, because you don't need it early on, and B, this helps to, most people would believe, this helps to foster a healthy microbiome now, or bacterial profile. In contrast, for iron-fortified formula, which is the only thing that one can get in the U.S. at this point, it is about 12 to 13 milligrams per liter, so several-fold higher than what a breastfed infant is going to be fed. Do we have any idea what that does to the microbiome? We'll talk about industry interactions. I have tried every major formula company. I've not been able to get someone to make me a low iron formula. But what we believe is happening, so at birth, from birth to 4 months, you have high ferritins, and that suppresses hepcidin, so that will block absorption. So if you have this very high iron intake, while you meanwhile have a high ferritin, you're going to have all this unabsorbed iron feeding the intestinal microbiome. And there's every reason really to believe that that's going to have an effect on your foundational microbiome. And should we care about that? Well, I think we probably should. So, but on the other hand, nobody's in favor of iron deficiency, and in fact, iron deficiency is quite common. We have limitations of the screening for infants and toddlers in the U.S. It's not done in the national surveys routinely. From 6 to 24 months. So just to remind you that iron deficiency anemia is the worst case, so that represents severe iron deficiency. And that prioritizes the hematologic effects of iron deficiency, not the brain linked. So we know you can be iron deficient without being all the way to anemic and have effects on brain development. And again, the first 2 years of life is a key time for brain development. So in the national surveys, there's no distinction on breastfed versus formula-fed infants. And of course, the breastfed infants are at higher risk because they're not getting these bucket loads of iron that the formula-fed infants do. So from the most recent national data published in 2016, looked at the rates of iron deficiency in 1 to 5-year-old U.S. children and anemia, as well as iron deficiency without anemia. And so you see over that time range, it's 3.2% are anemic and 7% have iron deficiency. So you might think, well, we can tolerate that. But in fact, if you look at the high-risk years, the second year of life, 1 to 2 years, well, then you have slightly over 5% actually anemic, and over 10%, 13.5% of toddlers have iron deficiency. And again, we don't have this divided by breastfed versus formula-fed. And there's no screening for under 12-month-olds. And so we really don't know what the prevalence is of iron deficiency in infants less than 12 months. So I'm going to come back to that. But I also just want to mention, while we're talking about that first year of life, or the first few months of life, zinc shows a very different pattern. So here we have, so up here is where iron is in formula at 12 milligrams per liter, and down here for human milk. Zinc starts out very high in human milk and comes down very precipitously, and so that by about 6 months of age, you're going to start cutting it pretty close. We have done nice negative studies looking at supplementing the mother to see if we can change this pattern, and have clearly demonstrated that you don't. This is a physiologic decline, so it's independent of maternal diet and maternal zinc status. The implications are that the infant's zinc intake also goes down over this time. So even though they're taking in a higher volume, that doesn't compensate for this sharp decline. And absorption is, again, like iron, it's quite high, 50% or 55% of the zinc that's ingested by a breastfed infant will be absorbed. But by about 6 months, the typical intake of a breastfed infant is about 5.5 milligrams per day, and the estimated physiologic requirements, so the amount you need to take in to support growth and losses and so on, is 0.84. So this is just an untenable situation. You're going to get deficient if you're only on human milk. So breastfed infants are dependent on their choice of complementary foods, or their parents' choice of complementary foods. So the impact of context, so again, the breastfed infant is really at risk for iron and zinc deficiencies. For iron, it's the infant changes and outgrows the stores that they're born with. For zinc, it's more that the milk concentrations change, but the combination is both of them have a need, are going to be dependent on complementary foods to meet their needs. Intake, however, is driven by energy requirement, not micronutrient needs. So it's, again, going to be the quality of complementary feeding that is critical. So plant-based diets are a bit of a concern because they typically have a much lower concentration of both iron and zinc, and if it is there, it's not very well absorbed. So this leads me into a study we did in the 2010, I think, is when we started it. And these were, we call it the Feed Your Infant study, in which we were interested. Zinc was really our primary nutrient, but we also looked at iron. So these were 5-month-old, exclusively breastfed infants who were randomized to either meat or infant cereal that was fortified with iron, or to the one product that has that is infant cereal, but fortified with both iron and zinc. And wanted to look at, we hypothesized would meat, which is a good source of zinc, meet the zinc requirements. Would the unfortified cereal be deficient, as we hypothesized, and what about the fortified cereal, and then also what about iron status across these three food groups? So I'm going to start with iron and show you, so as predicted, the meat group had a much lower iron intake here at a little, about 2.5 milligrams per day, versus the RDA of 11 milligrams per day at this or EAR at this stage. The iron fortified cereal groups, of course, had significantly, about a 3-fold higher intake. But when we looked at iron status, we saw that hemoglobin, ferritin, and transferrin receptors were not different by group. So a 3-fold higher intake did not result in a difference in status. 27% across all 3 groups had low ferritins, and 37% had high soluble transferrin receptors, which, as you recall, higher receptors means more risk of deficiency. And actually, this was the one, so there was a trend for the meat group actually to have a few more that had high soluble transferrin receptors. So, and 36%, these are healthy Denver breastfed infants. 36% were mildly anemic, and again, no difference by group. So we conclude from this that it's not just about the intake. We didn't see a relationship with intake. What we saw was rate of growth and also birth weight, and boys had a higher risk than girls. So it probably relates to their stores at birth and then how fast they grow and so on. So need to move beyond just how much fortification we can do and how much intake. So this brings me to how common might iron deficiency be in U.S. breastfed infants and toddlers. So remember, the NHANES data doesn't separate the two. And so I looked back we've done a number of trials over the years in breastfed infants and in Denver. And so what we see here is, so these are percent of iron deficiency, not anemia, by study. And these were across 9 to 24-month-olds. And basically what we're seeing is around 30%, 25 to 30% pretty consistently. And so when we looked at all of them together, it was 252 infants, and that average is right about 30%. The Iowa group that I mentioned before, with the ferritin levels coming down, they had a 35 to 40% rate of iron deficiency, and then a later or earlier Haynes survey showed again at about, but these were breastfed infants, around 15%. So how many U.S. infants would this affect? Of course, we know that we don't do as good a job of breastfeeding as we'd like, but we still, the CDC says that 26.7% of U.S. infants are breastfed at 12 months, and that translates to over 1 million infants per in the U.S. That are 12 months old. And so if 30% of them are iron deficient, that's over 300,000 infants. So that's not trivial. And so we are really not doing a great job, I would say, on addressing iron needs or screening or even identifying iron deficiency. And then what about zinc? Well, the risk of zinc deficiency, or is it really a problem with overload? So here we have different physiology than compared to iron. There aren't really stores of zinc, so you have to kind of get it in more regularly. It's also much harder to evaluate status. So we don't really know. But what we do know is that there's limited ability to compensate for low intake. So unlike low ferritin or iron stores, then you suppress your hepcidin so you can absorb more. We don't have that process that we know of with zinc. So deficiency is pretty predictable on the basis of diet. And so the breastfed infant or toddler who has minimal intake of meats or fortified products is going to be at risk for deficiency. And so if you look at it that way, we see lots of breastfed infants. I still run an infant clinic. We see lots of growth faltering, poor appetite, aka picky eater, and nice responses to zinc supplementation. So I don't think it's non-existent. And again, the high intakes that I was saying before that were above the upper limit were probably reflecting a combination of fortified products and then unrealistically low upper limit. And there's very low toxicity for zinc, and so much less so than with iron. So we really feel like we can supplement as needed for that, for if we think an infant is at risk. So to get back to our study that really started with the zinc focus, this is looking at the impact of different complementary food choices on the zinc intake. So here we have our cereal that's fortified just with iron, not with zinc. So this is basic infant rice cereal. And here's the one fortified with both iron and zinc. And so again, this and the meat group took in over the EAR. You can see by this stage the intake from human milk is trivial. So very small contributions. That's represented in the yellow bars there. The meat or fortified complementary foods cereal gave intakes that averaged above the EAR. When we looked at absorbed zinc, because again we were interested in the bioavailability, then only the meat group actually absorbed enough to meet the physiologic requirement. And even them, they didn't all meet that way. But here again, so this is on the y-axis here is the amount actually absorbed per day. So we labeled the breast milk and we labeled all the foods that they ate. And so the breastfed infants actually, with a combination of the meat and the milk, they actually absorbed right at the physiologic requirement. The fortified cereal group came close, but actually didn't quite make it. And then the unfortified cereal really supported our concerns that there is not enough adaptation to crank up absorption to meet the needs. And so here, the percent absorption was lower and the total absorption was only about 50% of the estimated physiologic requirement. So that suggests again that we need to get zinc into the diet for the older breastfed infant. So complementary feeding in the microbiome, just a couple slides on this. Does food choice matter? Well, yes. So I'm going to go over this very quickly, but we talked about the initial exposures at birth, prenatal, maternal exposures, delivery mode, breastfeeding or formula feeding, and then over here on this side, genes and mucus barrier function, immunity, metabolism, nutrition, kind of a big bucket. So breastfed versus formula fed, and then complementary foods, question. So I'm going to skip that on mechanisms, but just suffices to say that the colonizing bacteria communicate via a symbiotic relationship with the intestinal epithelium and immunologic elements and affect both innate immunity as well as adaptive immunity. And so this is a really key time when you're setting up tolerance to specific bacteria. And so you want to be choosing the right bacteria by what you're feeding your infant. So is all iron equal? If there's iron deficiency or iron deficiency anemia, is the answer just increase your iron intake? Well, we would suggest that perhaps not. So as I noted, dietary iron intake does not predict iron status. And so the high fortificant iron in infant foods and for infants and toddlers is very poorly absorbed, and it's even more poorly absorbed if you're already iron replete. So if you don't need it, you don't want to be giving it. So that would be the young infant as another example. Giving iron to iron replete infants has been associated with impaired linear growth in healthy or hygienic high resource settings. It's also been associated with increased levels of markers of systemic and intestinal inflammation, and also with alterations in the enteric microbiome. So this in our Feed Your Infant study, in a small subgroup, we looked at the microbiome, the diversity across the 3 feeding groups, and really all I want you to see here is that the meat group had a higher species diversity than either of the 2 cereal groups. And when we looked at the types, just to highlight one of the differences was that the Clostridium group 14A actually was highest in the meat group, and this is one of the short chain fatty acids, one of the butyrate producing groups. So we have a lot further to go on this, but this just illustrates that, and this correlated with the actual dietary iron intake. So we have a long way to go as far as really understanding what the effects of this may be, but this is just illustrating kind of proof of principle on this. And then very quickly on what about growth, this is a study we did in formula-fed infants, in which we randomized. Again, there's very little attention paid to the effects of complementary feeding for formula-fed infants, thinking they get all the nutrients they need. And so we sort of said, well, let's see what it makes a difference. So we randomized the protein source to either meat or dairy predominant, and set some guidelines on that, but didn't define exactly how much they had to take. But either you got kind of a yogurt-based or more of a meat-based complementary food, but again, all formula-fed infants, and they were all in the same formula. And we followed them from 5 to 6 months out to 12 months, and then looked at their growth and all of these outcomes. And I just have here a plot of the weight for age Z-scores, and you can think of them in percentiles if that's easier to think about, but basically 0 is like the 50th percentile here. And you can see that both groups, the meat in the dark and open circles is the dairy, both of them gained weight relatively similarly. They also note crossed the Z-score lines, which you're supposed to sort of stay in the same channel, but these are, they're gaining rapidly, relatively rapidly. And this is the linear growth, though. So much to our surprise, the meat group actually was fairly level and then increased towards the end. But in contrast, the dairy group actually declined in their linear growth. So when you put those together, you're gaining weight and you're growing longer, more slowly. Your weight for length, which is the equivalent sort of to an infant BMI, was significantly higher in the dairy over the meat group. And these differences now, we've followed these infants out to 24 months, and we still see growth differences. And we also, and I don't have these details to share tonight, but the microbiome differences have also been noted, and now we also have metabolomics and are looking into what is driving this and how much of the microbiome may be influenced by it. So the last section here, and I also want to wrap up, is infant nutrition evidence versus tradition versus marketing. So I would say that mostly what we've gone by is tradition, but marketing certainly has a huge role in how we have done complementary feeding, in the US at least. I don't want to speak for New Zealand. But this is marketing messages just by shelf space, and so product promotion is not necessarily aligned with complete nutrition. So here we have high emphasis on fruits and vegetables, cereal, and yogurt, none of which are good sources of iron or zinc. And so here we have 9 shelves, devoted to these products, and meat has, and new innovative packaging and so on. It looks very attractive, and meat gets one shelf in its old boring jars that are canned meat and smell terrible and so on. So I think there's a market opportunity there. And then these are some of the other marketing messages. There's all these little finger food puffs and things that, to my mind, encourage mindless snacking. Babies now have little carry-around bowls that tip and don't spill, and so they can eat anytime. And we don't necessarily encourage self-feeding skills or utensils. And then responsive feeding. To me, this is the antithesis of responsive feeding. The foie gras, or however you say that, the force-fed goose really comes to mind here. But, and then I don't know if pouches have invaded New Zealand yet, but again, very convenient, very easy to just squeeze the food into the mouth by the parent or the adult. And so this is concerning. So I think what we want to be promoting is, I mean, it's great. I certainly believe in whole foods, but what we want is nutrition and foods and health. And we also want to be respecting child development, and we want to be promoting good feeding habits. And we also need to give a thought to sustainability. So how do we balance all of these? And so I think there's some real opportunities here. And what this particular company has said, well, we don't say that we meet all the nutrient needs for infants, so that we just promote the fruits and vegetables and they can get their meat elsewhere. But I think we really need to think a little bit more holistically and not just focus on certain food groups that are cheap and sweet and palatable. So in westernized settings, the most micronutrient intakes are adequate. But breastfed infants are the one group that are actually at risk, and micronutrient needs there are very different from a formula-fed infant's needs. So iron and zinc are the outstanding examples of that, and it would be ideal if there were available products to match these needs that were acceptable. Fortification, I think it's really time to move beyond just supply side economics, if you will, and to think about the effects on the microbiome and immune development of how we think about nutrients, and really to think more broadly about holistic diets, and to think about the potential long-term effects of what we've done by tradition more than science. So again, I think we want to encourage healthy eating patterns and a variety of all food groups, and then think about age-appropriate feeding skills and responsive feeding. So with that, I will close. And